Okay, welcome everyone. This is the week 2 webinar for our statistics class. And let me tell you the plan for this webinar. I'll start out as always, and not just start, but throughout the whole time. Any questions you have, you're always welcome to put in the chat, or you can ask in using your unmute yourself and talk. And happy to talk about whatever questions you might have. And then we're moving to chapter 3. So I want to give you a warning about today. I like to think of this as a lot like kickboxing. It's really easy to watch someone else kickbox, don't you think? But if you have to do it yourself, it's a whole different story. Trust me, I used to do it. And kickboxing is hard. And chapter 3 is a little like that. It may not look very hard at all when you watch me do it. But this is a lot of people think this is the hardest chapter of the whole class. So because you got to come up with the way to do things, and each problem is like a word problem. It gets a little tough. So please ask questions. I'll do lots of examples, and we'll do the definitions and stuff. But it won't feel that hard to y'all because you're watching me do it instead of doing it yourself. But I will let you know doing it yourself is a lot harder. So be ready to get help when you need it, because a lot of people need help on this stuff. So I will start out with the definition of probability. Chapter 3 is all about probability. So very important in this whole class, we're going to be doing a lot of probability, and we'll do some of the, a little harder stuff this week, but we'll be using some of the easier stuff too. Okay. And then I'm going to give an example. And should I play the lottery again? So, by the way, you definitely don't want to come in and steal my ticket. You know why?
It's not real.
No, it's real. No, there's a real ticket. You can look close. It's definitely real. Yeah, this was last week's ticket. And it's a losing ticket. It's worth nothing now because it lost. But I'll talk about why I played. And we'll do some statistics to see why it was actually a good idea to play the lottery. Not to mention that way I can use it in class, and it sounds good and it wasn't that expensive. But we'll talk about what is the probability of a ticket like this, winning the lottery. Right now, the probability is 0 because it already lost. But when I bought it, the probability wasn't 0. What was it? And we'll talk about that. And I'm going to look at only the big win. I'm greedy. There's a lot of different ways of winning, but I want to look at the greedy, the $1.35 billion is what it was when I bought the ticket, if I won. And by the way, I didn't. Yeah, no reason to come in and steal my ticket because you'd be like totally wasting yourselves. Okay, then this is going to sound really easy. And because y'all know what and means, right? But it has very specific meaning in probability. And we're going to have some mathematical formulas based on the word and. When you see and, what do you write down in terms of probability? Then it's going to be like, looks so silly and easy. Well, look at the word or. Also sounds really easy, but when you have the word or, then you're going to have a formula that you use for probability. And again, the hardest part about this stuff is reading the question and try to interpret it, looking for keywords. Sometimes it won't be the word and, it could be the word both or something like that, which is the same thing as and. So there's English words that mean and you're going to have to be able to like figure that out. Same thing with word or. There's English words that mean or that aren't the word or. Okay, that happens. And then we'll have the word given. And we'll see if you have the word given, what does that mean? Then we'll look at what it means for two things to be mutually exclusive. Again, a lot of definitions, nothing hard to understand, but it's hard to use. That's really what it's about. And then we'll look at independent events. When are two events independent? And by the way, the opposite of that will be dependent. And we'll take a look at that. And then we're going to finish off actually by talking about Project One. So today's the day. I didn't want to talk about Project One last week because you were just starting the class and we were fresh, but now it's time to start thinking about it and you're ready to get started. Okay. Last week, all you were ready to do is find a partner, but now you'll be ready to actually work on the project and I'll talk about it. It's pretty intense. So I'll get into Project One. So are there any questions at all about anything?
Is
I
it
got
okay?
really lucky. Yeah, question?
Is it okay if you don't have a partner yet for the project?
It's legal, but I would say that you need to go work on getting a partner. Does that make sense? And you do that by using the discussion board. That's the easiest way. The
Okay.
other way of getting a partner is ask people here. You can put in the chat box, hey, I'm looking for a partner. But the discussion box is the one. And I want to let you know, it's a little complicated. When I do the webinars, I do them for both classes. So when you post onto the discussion board, it only shows your section. There's 2 sections, which are exactly identical except for the people in them. But everything about them is the same other than the people. But you won't be able to use Canvas to communicate with someone in the other section. So you would have to do that like, in chat or something like that. So just let you know that. Does that make sense?
Yeah, and then you're supposed to have you can have up to 3 partners, is that
Yeah,
correct?
up to 3, recommended 3 if you can.
Okay, cool.
Yeah, recommended 3. And you are allowed to work as long as you're okay with it. I can't force you, so I gotta be careful legally, but you are allowed to work with someone in the other section. But just note that you won't be able to communicate with them via Canvas. So you'll have to get some contact information like email and stuff like that. And yes, that's the biggie. But you can, but if it's in the same section, then of course it's easier in terms of that through Canvas stuff. Sorry about the complication. I don't have any ability to change it. I used to, and then they all kinds of laws. Lawyers like rule the world, it seems like. They made it so I can't do it anymore. Okay. So any other questions? Any other questions? Okay, if there's no questions, let me just do an example. Hopefully you've all seen these before. Yeah. Okay, and I do this for a couple reasons. One, even if a lot of you aren't in Tahoe, what's one of the main industries in Lake Tahoe besides skiing and snowboarding?
Casinos?
Yeah, casinos. So this is a big part of the Tahoe economy is cards. And do you think I ever made money in the casinos? What do y'all think?
I hope so.
Yeah, I made a lot of money in the casinos. But I needed to stop. It was stop or die. That was the choice they gave me. And I decided stop was a better choice when the mafia came. So that was the days. It was a long time ago. Things are different now. Now just let you know, you can learn all the statistics you want, but in terms of blackjack, for example, you won't be able to win. They actually hired me to help them change the rules so that people like me can't win. Okay, you get lucky and win, but you can't win like I did where I always won if I sat for 4 hours. A lot of money, just let you know. But cards are nice and easy for probability, so I'd like to bring that. So questions might be something like, what is the probability that if I pick a card, and it's very sad, this is Lakeside Inn cards, and they closed. But that happens. If I pick a card, what is the probability that this card is a king? And you might be able to tell me. And if you can't, that's okay. It's not okay if you can't tell me in 10 minutes, but if you can't tell me now, that's fine. Know how to find the probability, and you want to write it as a fraction. That's a hint. What's the probability there's a king?
1 out of 52.
4 out of 52.
Or 4, maybe.
Yeah, it's 4 out of 52. Okay, it's 4 out of 52. And by the way, I apologize if you don't know, if you haven't ever played cards. But there's 52 cards in my hand, and they call it deck. And there's ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. So there's 13 different values for the cards. And then for each value, there's hearts, diamonds, clubs, and spades. There's 4 suits. So 4 times 13 is 52, and that's why there's 52 cards. And by the way, I did pull out the jokers. So no chance of jokers, just to make life easier. Okay, so that probability is 4 out of 52. Very important to understand how these fractions work. So we're going to have a lot of fractions this week because we're dealing with probability. And when you have probability, that's how you're handling it. You're doing fractions. Okay, so what if let's do an easier one. One that everybody better know. Hopefully y'all know what that is. Yeah, what is the probability of getting heads? Okay, most of you probably know it's a half, but let me write out what it is so that we're ready for doing harder stuff. So I like to start with easy so you understand it, and then we'll get into harder. So let me insert an equation. So probability of heads is a fraction. That's the first thing. Probabilities are fractions. I mean, you could always do a division and turn it into a decimal, but the fraction actually tells a story better. Will be the number of heads over the number of sides. Okay. I know this is like none of you are going to sit there and do this like middle step because you're just going to do it. But this helps understand how to do probability. So probability means that it's a number of ways of getting what you're saying divided by the total number of things that can happen. So in this case, how many heads are there? And that's easy. There's one head, right? There it is. That's right. There it is. There's the head. So there's one head on that coin. Let me get to the fraction. And how many sides are there? Well, there's 2. Okay, I apologize if this is painfully easy. Hopefully you all agree that was painfully easy. And there's a probability of getting heads. Okay, do you think this is going to get harder? Oh yeah, yeah, it can get really hard, and we're going to do some. Okay, how about the probability of picking a card and getting a spade? Well, same thing. Okay, so what we can do is we can write a fraction. That's going to be the number of spades over the number of cards, right? Because it's the numerator is how many ways the thing in parentheses can happen. The denominator is how many different things can happen. And when we do that, forget the equal sign. How many spades are in a deck? And I see in the chat, I see a 13. And then how many cards are there? There's 52. Easy, right? Easy. Okay. So you're probably saying, wow, he said that it's going to be really hard. We're not there yet. Right, we're just at the very beginning. It's going to get harder, I promise. Okay, any questions on it? Okay, so here's again the formal definition of probability. And that is the probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. Another way of saying that is, and again, this is the notation you use. Mathematicians are boring. They don't try and be tricky. P for probability. Sound like the good letter to use for probability? Okay, because the first letter of probability is P. And then they usually put surround by parentheses, whatever you want to find the probability of. In this case, A, where we had heads or spades. So in general, it's probability of A. Okay, if there's two events, we'll say A and B. Again, we try to be boring. And that's the number in A divided by the number in the entire set. Okay. Notice, by the way, I didn't reduce this fraction. Sometimes it's better not to reduce fractions, even though like all of your childhood life, you were taught that you had to reduce fractions, right? But sometimes it's better. I think it tells the story a lot better to say 13 over 52. Because there's 13 spades and 52 cards. Whereas if you reduce it as 1/4, it's a little harder to see. Okay. Often, though, you want to turn to decimals. If you're ever going to do some math on it, then you divide the fractions using a calculator and then use decimals. And I want to let you know on the assignments and the exam, you don't want to do any significant rounding until the very end. So keep a whole like 10 decimal places or something like that. And at the very end, you round to however many it tells you to round. And that's something called the rules of rounding. Is that if you round early and like if you round 4 digits at the very beginning, you might get the problem wrong. So that's just a note about rounding, because rounding is going to happen in this section. Okay, here comes the next one. Okay, now we're going to get harder. Now I'm going to pick 2 cards. Just like so. Okay. Okay. In my hand, there's 2 cards. How do I find the probability that both are kings? Now, all of a sudden, it's a bit harder. You can't just count the number of both kings, because that's weird. Does that make sense? Any questions on that? So instead, what we're going to do is we're going to look at it one card at a time. Again, we pick these 2 cards. We're going to say, let's look at the first card. What's the probability the first card is a king? And hopefully you can all tell me. You've already told me once, I think, because I asked. So I'm going to write probability. I'm going to write K1 for, K1 for first is a king. Sound good? And that, again, we're going to go to a fraction. And there are 4 kings in the deck. And there are 52 cards. That's the first card. Okay, now you're only going to win if both are kings, right? Okay. So if I want to find out if I'm going to win, and I first look at the probability that the first is a king, guess what? First was a king. Now, what's the probability the second card in my hand is a king? And this one takes a little bit of thinking. How do you find? Yeah, what you have to do is you say, well, how many kings could this one be? And it can't be this guy. So there's only 3 kings left for this to be. Does that make sense? So if you want to find out the probability the second is a king, if we know the first is a king, then let me show you the notation first. That's the probability of capital P. Is it letting me? Let's try again. There we go. Probability that the second is a king. And then when we say if we know, sometimes we use the word given. And we put a little vertical line segment, and that means given, or we know that. And that's K1. So in this case, the probability that the second is a king, if we know the first was a king, there are 3 kings left because we know it's not the king that we just saw. And there's only 51 cards left in the deck because it's not the king we just saw. There's 51 other cards it could be. Any questions on that? Okay, so that's the first piece of it. Now what we're going to have to do is use what's called the multiplication principle. And that says, let me put this in red because it's that important. If I put it in red, it means we really care a lot. Probability of A and B, there's that word and. So probability that both happen. You do not win unless both cards are kings. Do you see that? So for probability of first king and second king will be the probability that the probability of A times the probability of B given that A occurred. And by the way, we can also write that as probability of B, and then you can write the little line segment, vertical line segment A, a little shorter, so you don't have to write all the words. And we say that's the probability of B given A. By the way, probability, hopefully you know this grammar, English grammar. A and B versus B and A. Is there any difference? No, they're exactly the same. So you could write probability of A and B as the probability of A times the probability of B given A, or probability of A and B is the same as probability of B times the probability of A given B. So in other words, you could switch to A and B and you're okay, as long as you do it consistently on left and right. Does that make sense? Okay. So you have to make sure that this becomes a B, this becomes an A, and this becomes a B, and then you're okay. Any questions so far? Okay, so now we can actually find the probability that both were kings. So probability of 2 kings will be the probability of king 1 times the probability of king 2 given king 1. Let me stop. Any questions on how I came up with that? How I put together the multiplication principle and the work that we've already kind of been looking at? That's what A and B are. A is K1, B is K2. Any questions on that substitution there? Okay, and then, well, I already have it because I've already found probability of K1. And probability of K1 was 4/52. And then I multiply that by the probability of K2 given K1. And probability of K2 given K1 is 3/51. Anyone lost on what I just did?
Isn't it supposed to be 4/52?
Oh, that should be a 4. Sorry, that was a typo. Thanks. Okay. Typically, in terms of what you're gonna have to do on the, on your online exams and assignments, is you have to write as a decimal. So I figured maybe I'll show you how to do that. That's nice and easy. We can write that as 4/52 times 3/51. And I get this outrageous number. And if we wanted to round to 4 decimal places, we notice that the 4th decimal place gives you 0.0045. Notice the next one's a 2. 2 is less than 5, so it means we don't have to change anything. We don't have to round up. We just keep it as 0.0045. Any questions on that? Any questions? Easy enough? Okay. So here's the next question. Okay. Suppose you pick 5 cards for a poker hand. What's the probability of getting a royal flush? Now, let me explain a little bit in case you don't know what poker is. I can't assume you know how to play games, right? When you have a poker hand, all that means is the dealer deals you 5 cards. Got it? Okay. And we're not getting too sophisticated. We're not gonna be able to grab new cards or anything like that. They just gave you 5 cards. What is the probability that these 5 cards are royal flush? Now, royal flush means ace, king, queen, jack 10 of the same suit. Any questions on that? Okay, now this is going to get harder. Okay, so we're going to have to find out. I'm going to do the easy one first. Okay, so that's going to be the probability, the number of royal flushes. Let me write number of royals. Just write royal over the number of hands, poker hands. Any questions on that so far?
Is this still the multiplication principle?
You could do it that way, but I will let you know that would be absolutely brutal.
Okay.
So this is going to be a new way. We're going to just do the counts and we're just going to go for it. Yeah, well, it would be, I'm not even going to go on how to do it with multiplication principle because it would take hours. We don't even have time if that was the only example for the whole webinar. Just let you know, we're not going there. But we can do it the way I'm about to show you. Okay, number of royal flushes, that shouldn't be hard. How many ways are there of having ace, king, queen, jack 10 of the same suit? And by the way, order doesn't matter. So ace, king, queen, jack 10 is the same as king, ace, queen, jack 10. We're going to call that the same thing. That's not 2 different things.
4.
Yeah, there's 4 because you can have hearts, diamonds, clubs, and spades. There's 4 suits. So that's easy. Now comes the harder part. How many different 5-card hands are there in poker? How many different ways are there of getting 5 cards where the order at which you are dealt the cards doesn't matter? So like I said, ace, king, queen, jack 10 is the same as 10, jack, queen, king, ace. Okay. Now that is something I don't expect any of you to just come up with. So I'm going to show you. And what we do is we go to my calculator. Okay. And we are right here at combinations and permutations. Notice we've already done z-squared. That was last week, right? So I'm going to combinations and permutations. When order doesn't matter, that's called combinations. When order does matter, it's called permutations. And C for combinations, P for permutations. N is how many. Oh, there's a typo there. I'll have to fix that. I got to remember after class to do this. That should be an R, not a 4. To fix that in the calculator. So N is how many you're picking from, and R is how many you're picking. So in the poker example, how many cards are there to pick from?
52.
Yeah, it's 52. How many are we picking?
5.
Yeah, 5. Okay. And order doesn't matter. So it is the CNR, which stands for combinations. There's a lot of math behind it. I'm not going there. What you have to do, this might be the first time, it's not the first time actually, but it's another time that I'm telling you, trust me. Sound good? Trust me that I did all the math and all you have to do is understand what to put for N and R, and that if order doesn't matter, you hit CNR. Okay, and by the way, it's a big number. There's no way in the world you are going to be able to list every 5-card poker hand because there's over 2.5 million of them. Good luck. Okay, but there is a way of doing this mathematically, and even better, there's a calculator that does it for you. And mine isn't the only one that does it. Okay, but I tried to make it easy. Do you agree that was pretty easy to look in the calculator? Okay, so it's 2,598,960. That's how many different token hands there are. So I'm gonna put that there. And there's the probability. Okay. By the way, do you think you should like hope you just get lucky? Go for the bet and go for it? Is it a high enough probability that you went for it? No. No, very low probability, by the way. Okay. This is again, you can actually compute it. We'll go back to the calculator. And this was 0.0. I'm sorry, this was just a minute. Actually, let me show you this way. Scientific calculator, because that's how you'll probably be doing it, because it's easier. And then we're just going to take 4 divided by that. And I do want to show you this 10 negative 6. What does that mean?
Zero?
Hmm?
0?
0, huh?
Never mind.
Now, it's very important to know what that means. Okay, so 10 to the negative 6. That means you need to move the decimal to the left 6 places. The first time the decimal will go next to the 1, right? To the left of the 1. Then you have to stick in zeros each time you move it, and you're going to have 5 zeros before you even get to the 1. So you have 5 zeros and then 1539. So let's just do it that way. One, 2, 3, 4, 5, 1, 5, 3, 9. And there's your probability of getting a royal flush, which is like in between 1 and 2 in a million chance. Any questions on that? Okay, I do want to let you know that this is what's called 5-card stud. You don't get to like get new cards by throwing some away and stuff like that. It gets very complicated if you do that. But there's elementary stats, I can't go into that stuff. Okay, I used to teach a class called the Mathematics of Poker. And we did some of that, but I can't do that in this class. Okay. So here's another one. Suppose you guess randomly on a 20-question 4-answer multiple choice quiz. Okay, so you got a multiple choice quiz. Each question has 4 choices, and you have no idea what the answers are. So you just guess. What's the probability of getting all 20 of them right? Okay. So this one's a little different. This one's a lot easier. So we want to think about it. And let me go and realize we're going to use the multiplication principle. So what I can do is I can say, let's look at the first one. What's the probability of getting the first one right? Yeah, so the question was, what's the combinations, permutations? Combinations mean order doesn't matter. Permutation means order does matter. Okay, yeah, the probability of getting the first right is 1/4. Hopefully you all can do that. There's 1 right answer and there's 4 possibles. Okay, now if you know you got the first one right, does that change your probability of getting the second right?
No.
Not at all. So it's very different than the card example. This is called with replacement. So it means that you can still guess any of the 4 for the second one, A, B, C, or D. That knowledge of the first one tells you nothing about the second one. Does that make sense? Whereas with the 2 king example, knowledge of the first made a difference for the second. Does that make sense? If you knew you got a king, you had a smaller chance of getting a king the next time. Here, if you know you got it right, you don't have a smaller chance or a bigger chance of getting it right again. It's always going to be 1/4. So we're going to have to multiply for the second one by 1/4. How about the third one? What's the probability of getting the third one right? This should be really easy. Yeah, 1/4, nothing changes, right? And the fourth is 1/4, and the fifth is 1/4. So you can have 1/4 times 1/4 times 1/4 times 1/4. And you're going to write that 20 times. What's another way, a nicer way of writing 1/4 times 1/4 times 1/4 20 times on itself? Do you remember? Kind of basic math, but
125 to the 20th power.
yeah, or 1/4 to the 20th power. So I can rewrite this as 1/4 to the 20th power. Any questions? Okay. And you could, if you know it's 0.25, that's fine. If you don't, you can use a calculator. It's all your choice. Okay. Any questions on that? Any questions? Okay. And by the way, easy to put in the calculator. Whoops, let me erase the last stuff. There we go. And I think I need it in parentheses, actually. All right, very small chance. By the way, there's 12 zeros to the left of that 9 because of that 10 to the negative 13th. Any questions on that example? Okay, so that's width replacement. Okay. So here's the next question. If I play the lottery again, okay, by the way, what's the probability of this being a winning ticket, given what I told you at the beginning of class? Is important. Yeah, 0. I told you it was a losing ticket. Yeah, once you know it's a losing ticket, the probability is now 0, period. It's not a winning ticket, okay? I'd throw it out, except I wanted to use it for class. Does that make sense? And I did check. I'm not stupid. Okay. But let's see what if I buy another one now, what's the probability of a winning ticket? So the first thing you have to do is know how to play. This is, by the way, Mega Millions. So you have to know how to play Mega Millions. So let's go to the lottery's website. And if you go to how to play, then it tells you all the different things you can do. And step 1 is pick 5 numbers between 1 and 70. And 1 mega number between 1 and 25. Okay. By the way, the 1 mega number between 1 and 25 can be the same as one of those that you picked between 1 and 70. But the 5 numbers you pick between 1 and 70 can't repeat. So the 5 numbers between 1 and 70 is a lot like the card example, but now we can think of having a 70 card deck instead of a 52 card deck because we're picking 5 numbers out of 70 possible numbers. Do you see that? Any questions on that idea? So now we can actually do the calculation. Any questions on that? Okay. And by the way, let me show you the ticket. You may not be able to see it too well, but you'll see that if I buy something like this, I actually bought 2 sets of numbers. I did it because I wanted to make sure that we can include this part in the class. So if I bought 2 sets of numbers, this should be really easy. How many ways are there of me winning if I buy 2 sets of numbers for the next lottery? Yeah, 2. Okay, hopefully that was really obvious, right? Either the first set can win or the second set can win. Any questions on that? Okay, so if I want to find out the probability of winning, then I can first make a fraction, and I know that the numerator is a 2. Because I have 2 sets of numbers. Okay, and by the way, if you don't know, then it's $2 per set of numbers. So this actually cost me $4. Okay, and that's just how the lottery works. That's not math. Okay. Okay, anyone play the lottery here? I'll help you. I'll show you before you play the lottery when it's a good idea. Okay, now we want to find out, well, how many different ways are there for these numbers to come up? Well, they're going to pick 5 numbers between 1 and 70. And whether you know or not, I'm telling you, when you're playing the lot, when they're picking numbers out for the lottery, order doesn't matter. Okay, so if they pick, 2, 15, then 23, that's the same thing as 23, then 2, then 15, for example. Okay, so order doesn't matter when they pick numbers for the lottery, for the mega numbers. So what I can do now is I can say I'm going to pick 5 numbers between 1 and 70. Well, there's 70 choices, and I'm going to pick 5 of them. Do you see that? And I can calculate, and it's not that good. Okay, that's over 12 million. So just a note, let me copy that. Let me pop that in the denominator. But we're not done yet. How come we're not done?
Because the mega.
Yeah, we still got to have the mega number correct. Well, for the mega number to correct, well, that you have to multiply by 1 over 25. Because that's the probability of getting the mega number correct is 1 over 25. If there's 25 numbers, you're only picking 1. So I can stick that in the denominator as a times 25. Okay. And it might help to do the following, just to see. In my calculator. Okay, so if the numerator is 1, I would have 1 in 302,575,350. Do you see that? Okay, is that a good chance? Like, should I have bought a $20 million house and put my bid on it because I know I'm going to win? What do you think? No. But here's the deal. It cost me $2 per ticket, right? So if I double this number, I get 305 million about, right? I'm sorry, 605 million. Does anyone know? I bought that ticket last Thursday. Anyone know what the lottery was worth for that lottery prize? Anyone remember? About? It was about $1.35 billion. Yeah, not 1.8, 1.35. It was $1.35 billion. And I had a 1 in 302 million chance of winning. And if I double that in terms of the price, that's only 1 in 600 million. So the amount winning is actually more than you can think of the amount winning, total amount won is more than the amount that, the probability. Do you see that? The denominator of the probability. So it turns out next week, we're going to do something called expected value, and we'll see that it was actually a positive expected value for me to play the lottery. So statistically, it was a good idea. It's more complicated than this because there's other winnings besides the super win. But I will let you know I had a positive expected value last week. Does not mean I'm going to win, but it means it's a good bet.
So you could have bought all possible combinations and you ended up winning profits.
Yeah, the only problem, which I didn't mention, well, one thing is I couldn't have bought all the odd, all the possible combinations because it would have cost me, it would have cost me $302.6 million.
But I mean, it would have been a good.
And I don't have enough money to do that.
You would have made back your money guaranteed.
Right. So there's guarantee, except there's one other little issue which I didn't get into because the statistics are a little hard. And that is there's a chance that someone else is going to win also. And they have to split the money.
Not only would you win the big jackpot, you win all the smaller prizes too.
Yeah, then the smaller one, it gets too complicated for this class. But I'm also I'm not rich enough to be able to buy that many tickets. I'm a teacher. I'm not poor, but I certainly am not anyone that can just, I think I'll spend $302 million. And that way I'll be guaranteed because no one's going to blow me the money. If that makes sense. Okay, but it's a good question. Good question. And people have done that kind of stuff where they wait until it's a positive, what's called a positive expected value, which will be next week's thing. They buy a whole bunch of them and they make money. They did that, I think, in New York. Okay. Any questions at all on this example? Okay, let's look at more examples. Okay, today's example day. Have you noticed that? There's not a lot of vocabulary. I mean, there's and, or, given. Okay, so I want to look at one of these because I call this a wordy problem. And that's one of the hardest parts about this stuff is to read a long paragraph and come up with the answer. Okay, so, okay, and by the way, I want to note, if I say suppose, that means I'm just making it up. Don't quote me or write a paper on it. Does that make sense? But I want the numbers to be nice, okay? So suppose that 20% of all students taking stats at Lake Tahoe Community College are African Americans. And 40% of all stats students are at Lake Tahoe Community College are non-STEM majors. Okay, if 22% of LTCC students, non-STEM majors, are African American, and you pick a randomly selected African American taking stats, find the probability that that student is non-STEM. So do you agree when you read this? It's a little scary. It's a lot of words. So here's my suggestion on handling problems like this, and you will have to do some of these. First thing you should do is do exactly what I just did. Read it. Sound good? But don't try to understand everything, just read it. Then what I recommend is read it again, but very slowly. And every time you see a number, decide what probability that number represents. So suppose that 20% of all students taking stats at LTCC are African American. Okay, well, what we can say is that probability of being African American, how about A for African American? Sound good? Is equal to 0.2. Okay. And this entire paragraph, by the way, that's when I read it, everyone's taking stats. That's the whole population are people taking stats. So we don't have to worry about them taking stats or not, because everyone's taking stats in all of everything this is saying. Any questions on what I just wrote and how I came up with that? And hopefully you all know 20% is 0.2. It's very important to know how to turn decimals, percents into decimals. Okay, 40% of all stats students at LTCC are non-STEM majors. So that's probability. How about N for non-STEM? Sound good? Okay, you can choose a letter. You can call it B if you want. I like to use the first letter or something, but you can do whatever you want. Okay. O is kind of a bad idea because it looks too much like a 0, just to let you know. Okay, so P of N is equal to 0.4. Any questions on that? So do you see how I'm rereading the question one little piece at a time? When I see a number, I write it down as in symbols as a probability statement. Okay, if 22% of LTCC stats students, non-STEM majors, are African American. Okay, that's a probability. So now we're only looking at the non-STEM majors. Okay, so we're given that someone is non-STEM. 22% of them are African American. Do you see how that works? So that's the probability of A given N. And that's equal to 0.22. Any questions on that? Okay, now you pick a randomly selected African American taking stats. Find the probability the student is non-STEM. So we want the probability of non-STEM. If we know they're African American, so that's the given African American. And I'm going to write equals question mark because that's the question. So let me stop. Are there any questions on how I came up with any of these four statements from reading this paragraph? Any questions on that? Okay, if there's no questions, we have this given thing, and let me remind you. Right here, multiplication principle. I'm going to copy and paste it where I am because I'm going to use it, kind of. That was a multiplication principle. If I take this multiplication principle and I switch the A and the B, which I can do. So make that A a B. Make the B an A. Make this A a B. Remember, you can do it either way, whatever you want. And if I divide the left and right-hand side by P of B, I get this formula right here. And that's the probability of A given B is equal to the probability of A and B times the probability of B. That's just taking this P of B and sticking it as a denominator under the probability of A and B. A little algebra, you can divide both sides by probability of B. Any questions on that?
Are those both the same equation? You just have to follow the same order?
These two?
Yeah.
Yeah. This is just whichever one, you can call whichever one A and B you want. That really makes no difference when you have an and, right? Probability of someone being African American and being non-STEM is the same as probability of being non-STEM and African American. Does that make sense? That's just English, right? Because the statement says exactly the same thing. Is that clear?
Yes.
Yeah, so I wrote that and I figured I'd rewrite it so I can write this formula right here. Okay. So we have this important formula. So now I need the probability of A and B. Or in this case, I need the probability. Let me bring that one back. And instead of A and B now, we know A given N. Do you see that? So if we want the probability of A and B, we can think of it this way, or we can think of it this way, like this one, which I think is a better one for what we're going to be doing. So now I can say the probability, so A, we'll still call it A, and N is equal to the probability of N, which is 0.4, because we already found that out right here, times the probability of A given B. So in this case, it's the probability of A given N, which is 0.22. Any questions on how I came up with those two numbers? Because we have the A given N is 0.22. We have the probability of N is 0.4. Put those together, and that'll give you A and N. So now we can take this probability formula. That's what we want. Okay, now we want N given A. Okay, and I guess I should write, yeah, so that's probability of A and N divided by probability of A. Any questions on that probability? Now we just put it all together. Probability of A and N is this 0.4 times 0.22. Probability of A was 0.2. Okay, I don't think I can waste your time. I think you know how to put that in a calculator, right? Multiply and divide. Okay, any questions on how I came up with the answer to this very difficult question?
I have a question.
Sure.
I'm a little confused on the last part, the probability n given A. The numerator,
Mhm.
the 0.4 times, because
Right,
it's
so
A and
that's
N. I'm just confused why it'd be both.
okay. So here's the numerator right here, P of A and B.
Mhm.
So the and, that's what we had just figured out. P of A and N is right here. So I basically just copied and pasted right in. Do you see?
Okay.
Because that's
Gotcha.
the and. We did all the work for that. So I just rewrote it.
Okay. Okay. Thank you.
Okay, great, great. And good questions. And again, you know, the webinars are all about Q&A. So it's good that you're asking questions. Any questions at all on this? Any more questions? Okay. Let me not get to those because I want to get to contingency tables. They're important because these come up a lot in our class, in other chapters too. All right, so this is called a contingency table. And this is done a lot in the real world. So let's suppose that a survey was done asking Lake Tahoe Community College transfer students where they plan on transferring to and what living situation they will be in when they transfer. Okay, and this is a table that shows the answers to the survey. So for example, this number 7 meant that there were 7 students in the survey who are living with their parents and are going to transfer to UNR because that's parents, UNR, and a 7. Do you see how that works? So that's how you read the table. And it's called a contingency table. So here's a question. Find the probability that a randomly selected student will go to a UC campus or live in an apartment. Okay, and just to save us some time, there are 246 students. If you add up all these numbers, you can trust me, you get 246. So let me give you an important formula first. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And this makes sense when you think about it, because what you're doing is saying, well, what's the chance of getting A? What's the chance of getting B? But if you got both, you've double counted. Because this guy has all the A's, this guy has all the B's. If you're in both, then you got counted here and you got counted here. So what this does is it subtracts off the double counting. That's where the formula's coming from. So you can memorize it or you can try to understand it. I'll let you choose. Okay, any questions on the formula first? Okay, so now we can go ahead and do the problem. We want the probability of going to a UC campus or living in an apartment. Let's call that A for apartment. Sound good? Any questions so far? And that's what we want? That's equal to the probability of a UC campus plus the probability of an apartment minus the probability of UC and apartment. Any questions so far? Okay, now let's go to the UCs. How many students are transferring to UC? And here's the UCs. How do we find out how many are transferring to the UCs?
You add those three numbers up.
Yep. You add the three numbers up. And I think I'll just be lazy and go 33 plus 8 plus 19. And that's 60, but you don't have to be able to do it in your head. Okay. Divided by the total number of students, which was 246. Then we go plus the probability of an apartment. So same idea. So probability of an apartment, well, we have 43 plus 33 plus 19, and then plus 22 divided by 246. And then we go minus the probability of UC and apartment. That's really easy. What's the numerator for the probability of UC and apartment? It's very easy. Yeah, 33 over 246. Okay. And by the way, the reason why this formula works is notice this 33 gets counted here, and then it gets counted again. So 33 gets counted twice. So what you're doing is you're saying, well, I've counted the 33 twice, and then I'm getting rid of one of them. So now I've only counted it once. That's really what happens in the formula. But it's good to know this formula. Any questions at all on this example? Any questions? Okay, and again, the warning is it's so much easier to watch me do it than to do it yourself. Okay, I'm not going to waste your time, but hopefully you all know how to put this in a calculator. Hopefully you know how to do arithmetic in a calculator. That is kind of something I assume. If not, you can always go get help. But it's just, you got to remember to put parentheses around the 33 plus 8 plus 19 before you divide by 246. If you don't put the parentheses, it'll only divide the 19 by 246.
I feel like this is a silly question, but how did you get the last 33? Sorry.
Oh, that was right here. So that's UC right here, apartment. If it's both,
Oh,
then that's what this number means. Do you see how that works?
yeah.
Yeah, that's the definition of these numbers. Is you read, what column, what row it came from, and that means both of those happened.
Okay, thank you.
Okay, so next. Two events are mutually exclusive. So a new word, or new two words, I guess, definition. If the probability of A and B equals 0. So before I do this example, let me give you an example. If I pick a card, and let's say A is that it's an ace, and B is that it's a 6. Are those mutually exclusive? So A is that it's an ace, B is that it's a 6.
I'm gonna guess no.
One more guess.
Yes.
Yes, this cannot be a 6 ace. Do you see? It can't be both an ace and a 6. It's one card. Do you see that? So the mutually exclusive, you can't have this card being both an ace and a 6. Doesn't even make sense, right? Okay, on the other hand, let's suppose that event A was that this card is a king, and event B is that this card is a spade. Are those mutually exclusive?
No.
What do you think? Are those mutually exclusive? The answer is no, because here we go. I have a king of spades right here. So the probability of a king and a spade is actually 1 in 52, not 0. You see how that works? So basically mutually exclusive means they can't both be true. Another one would be, let's suppose you're looking at people, and let's say event A is that they were born in California, and event B is they were born in Alaska. Is that mutually exclusive?
Yes.
Yeah, you can't be born in California and Alaska. Doesn't make sense. Do you see how that works? That's a probability of 0. But if it was born in California versus, say, born in Los Angeles, those are not mutually exclusive because you could be born in California and Los Angeles. Do you see how that works? But the equation is probability of A and B equals 0 if it's mutually exclusive. So are transferring to CSU and living with parents mutually exclusive? So if we go up here, then we'll see that there are 34 students who transferred to CSU and are living with a parent. So the probability of CSU and parent is 34 over 246. And that's not 0, so those are not mutually exclusive. Do you see that? Any questions on mutually exclusive? Okay, here comes the next big definition. Two events A and B are independent if any of the three are true. Probability of A times and B equals the probability of A times the probability of B. Probability of A given B equals the probability of A. Probability of B given A equals the probability of B. Okay, if one of them is true, they're all true. If one of them is false, they're all false. And again, I don't have time to show you all the math behind it, but do you trust me that's how it works? Hopefully you trust me. Okay. So if you want to show they're independent, then you could choose this one, or you can choose this one, whichever one you feel like that day. And really the way to do is whatever one you think is easier is the one you should use. Does that make sense? And different situations will have different ones being easy. And if you show that, whichever one's easy is equal, gives you the equal, then you say, yeah, they're independent. Whereas if you get different numbers on the left and right, then you say they're dependent. So are living in an apartment and transferring to UNR independent? So the probability of apartment given UNR, I want to show you this. So the probability of an apartment given UNR are going to be the number of people who live in an apartment who are transferring to UNR, because we're only looking at the UNR group if we're given UNR. And the number of people of the UNR people in an apartment is 19. And the total number of UNRs are 19 plus 7 plus 15. which is 41. You can trust me on that, or you can do it yourself. So we can say that, where were we? Probability of apartment given UNR is 19 over 41. And I stuck that in a calculator and I got 0.463 and a bunch of other numbers. On the other hand, if I want to look at the probability of just being in an apartment, that would be 43 plus 33 plus 19 plus 22, which I got 117 when I add them up. There were 246 total, and I got 0.475. Are they the same? Are they equal? Yeah, if they're not equal, then we can say that living in an apartment and transferring to UNR are dependent. Any questions on that? Okay, so this is kind of the math way of thinking about independence and dependence. Kind of the way of like the feeling way of doing it instead of the math way is you say, well, if you know about one, does it tell you anything about the other? So an example I like to give is, how about the high temperature in Lake Tahoe on that day? And how many points the soccer team got in New Zealand high school on that day? Do you think the temperature in Tahoe has anything to do with the number of points that the soccer team in the New Zealand high school in New Zealand got? Nothing to do with each other. So those would be independent. Do you see that? Because knowledge of one tells you nothing about the other. If I told you that the high temperature today is 34 degrees, if you're not from Tahoe, that sounds cold. If you're from Tahoe, you're wearing a jacket like I was today when I was outside. But it's 34 degrees. Then that doesn't help you at all in guessing what the soccer team, the high school soccer team in New Zealand is going to score. Do you agree? So if one thing doesn't tell you anything about the other, then they're independent. On the other hand, if one thing does tell you something about the other, then they're dependent. Okay, give you an example of how I use this personally. When I was a card counter, the cards that I had already seen used in the blackjack table helped me understand the probability of me winning. So the past cards and me winning were dependent. And because of that, I was able to decide whether or not my chance of winning was better or worse, and that I'd actually bet more money if my chance of winning was high. That's called card counting. So that was how I used it personally. Any questions on the idea of independence? There's a math in the idea. Okay, if not, here's the secret word. Okay, I tried to give you an easy one. If you don't know what this word means, then you have a problem. And the secret word is and, because and is one of the key words in probability. Okay, so we still have some time. So what do you think? What I tell you we're going to do in the last bunch of minutes? If you don't remember, project one. So we're actually done with taking notes or that kind of stuff on, math. Now it's time to think about the project. And I want to go over the project and all the things to think about. So let me just go to your class. And the way I like to do it is I go to the syllabus. I think it's the easiest. Okay, there's different ways of getting to the project, but this is one of them. And just a note, here's project one. And as I mentioned at the beginning, and I'm going to mention again, you're required to work in partners and groups. 3 is best because it's less work for you. And also it gives you a backup in case someone drops. Okay, but if you can't find 3, you could do 2. You're not allowed to have 4. So if there's 4 of you, split up into 2 groups of 2 and see if you can each find another. And if you can't, 2 is okay too. Does that make sense? Okay, so no single person. You got to have your name. And just a note, 25% penalty will be incurred if you cannot work with another student. So basically, you can't even get a high C if you don't have a partner. So you need to have a partner. Does that make sense? Okay, so, and which isn't hard. You can post in the project discussion board and find yourself a partner. Okay, so you get a partner. That's step 1. And timeline, I like to give you timeline. Timeline is that should have already happened. If not, you should be worried and you should get a partner like today. And again, post in the discussion board and get your partners. Okay. Then what you should do is you should click on project 1. Okay, let me go through what you're going to have to do for project 1. So think of a quantitative investigation. Who remembers what the word quantitative means? Okay. Yeah, it means that it's a number answer to the survey question. So what I recommend doing is writing down the survey question and literally asking your partner the survey question. And if the partner's answer is not a number, then this won't work. Does that make sense? And both partners, you're going to get 2 different numbers out of your 2 partners. Does that make sense? Okay, you might get the same, but most likely you get 2 different numbers. Any questions on that? So you're going to think of a quantitative survey question. Okay, it has to be something that somebody would be interested in having done, to contract you out to do it. Now, I will let you know that this is hypothetical. You're not required to actually get someone to hire you, but you are required to pretend you got someone to hire you. Sound fair? Okay, so you're supposed to pretend that someone hired you. Okay, any questions on that? And that someone could be President Biden. You could pretend, good luck getting him to hire you, but you could pretend he hired you if he'd be interested. Does that make sense? Okay, it could be the president of our college, Jeff DeFranco. It could be, I don't know, it could be Kamala Harris. It could be, whoever it might be that someone would be interested in hearing about your results. Does that make sense? So the person that is hiring you is who you're writing this to. One thing you could assume, even if it's not true, is that they understand statistics. So you're supposed to use statistical vocabulary, by the way. Any questions so far? Then you're going to go and perform the investigation, and you're going to produce a report as though you were writing it to the person who hired you. Okay, this is really important, which most people don't pay attention to, but I want to really focus on this. The purpose of the report is to make recommendations based on your findings. So everything you find, you're supposed to use it to make a recommendation. And just to let you know, things that you're going to be finding are going to be the mean, the standard deviation. You're going to find a z-score or more than one z-score. You're going to find the median, the minimum, the maximum. You're going to find charts. You're going to find a histogram. You're going to find a stem and leaf diagram. You're going to find a box plot. So all the different stuff that you did kind of the first week, but now you're going to have to do it much more in depth. Okay, so each time you even mention one of those things, you're going to give a recommendation to your client based on what that thing is telling the client. Any questions on that so far? Okay. You're going to have to do a survey. Shouldn't be too surprised about that. And in your survey, you have 3 choices. You can either use simple random sampling, you can use stratified sampling, or you could use cluster sampling. But I want to give you a very strong warning. Can you really use simple random sampling? Probably not, okay? Because simple random sampling is almost always impossible for people. And you're doing a survey of people, by the way. Okay. Now you are allowed to ask online. You just have to make sure you get enough, answers. There's an online class. So again, you're allowed to sit in your bed the entire class. It'd be kind of boring. Like for the next 12 weeks, never leave your bed. You're gonna have to hire someone to give you food. And you can still pass the class and do everything, including the project. But you're also welcome to walk up to people and ask them personally, you know what I mean? So that's up to you. But I want to let you know that you can go either way. You can do online surveys or you can do a in-person survey. That's totally up to you. And when I say you, I mean y'all, as in the three of you or the two of you who are partners. Does that make sense? Make sure you're in agreement because you're doing one project for your group. Okay, so notice I didn't even put a link to simple random sampling because no one really does it. It's too hard. But I do have a link to stratified sampling and cluster sampling in case you forgot what those were. Yeah, you could do both in person and online. You could do a combination of the two. You're allowed to do that. But you do have to ask people. That's required. Okay. By the way, 2 years ago, you were only allowed to do online. Do you know why? Not you, but the class. Yeah, COVID. I wasn't going to let people get COVID because of my project. But we're, hopefully you're vaccinated and you're safe. You can wear a mask if you want to. That's up to you. You need to discuss any bias that occurred due to your sampling technique. Note that bias involves a misrepresentation of the population so that the sample data will not represent the population data. So in just talking about the bias, don't just say there's bias. You're going to talk about what the bias is going to do to your sample. Is it going to make the mean lower, for example? Is it going to make the mean higher because of your bias? Does that make sense? Okay, and you should think about it. And if it doesn't change the data, you ask a certain type of person, but that type of person is going to be like everyone else, then that's not bias. Okay, but there's going to be bias. There's going to be reasons for bias. Doing a survey without bias is pretty much impossible. Could be voluntary response bias, could be bias because of the people you asked. There's all kinds of bias. Okay. And by the way, when you do stratified sampling, it's fine to just do one type of strata. So you could do, for example, race or gender, or income. You just choose one of them. Don't make it too complicated. Does that make sense? Okay. Any questions on this so far? Okay, so very important. You're going to have bias. This is also very important. The variables must be quantitative. I can't say that strongly enough. It's a complete disaster if you have a qualitative study because you won't be able to have any statistics except proportion, which isn't what this is about. So has to be qualitative, and the sample size must be greater than 30. By the way, what's the smallest number greater than 30? This is not a hard question. You all better know this. What's the smallest number of people you could ask? 31, okay? 31 is fine. If you ask 100 people, I'm not going to give you any more points than asking 30. So don't waste your time. No reason. The only reason you'd ask 100 people is if you had a real client that's paying you money. Otherwise, don't even think about it. Does that make sense? So 31 is fine. 32 or 33 could be fine. 33, so maybe each of you ask 11, that kind of thing. That way, if there's 3 of you. But you don't have to go much more than 30, but it has to be at least 31. And I want to let you know, this is going to be a very big deal in a couple weeks. We're just not there yet. but this is going to be the magic number to be able to do a study that's actually with the big enough sample size when you have quantitative data. So right now I can't get into why, and you won't for your project either. Just say that you surveyed 35 people or 32 people or 31. Does that make sense? Okay, just to note, because a lot of people do this, if you're going to do stratified sampling, let's say you did stratified sampling with online and face-to-face students, and your population were all students, okay? Maybe all community college students. Then that does not mean you're comparing online to face-to-face. It just means that you're doing the stratified sampling so that you don't have a misrepresentation, too many online or too many face-to-face. So your data is going to be one column of data, period, if you're doing stratified, not two columns. You're putting it all together in one column. Any questions on that? Okay, you must include a histogram. You must include a stem and leaf. And you must include a box and whiskers plot. Just to note, what would be wrong with saying something like, how many colleges have you attended? What would be wrong with that for this project? It's quantitative, right? I've actually attended 4 colleges in my life. What would be wrong with this? Why would this not work for a project? The hint is I've highlighted something. You know? Okay, stem and leaf diagram needs 2-digit numbers. And pretty much no one has gone to more than 10 colleges, taken classes in more than 10 colleges. So you're not going to have a stem and leaf diagram that works. Does that make sense? Because all of your answers are going to be single digit. So you won't have a 10s digit and a 1s digit. Does that make sense? So make sure that you get a variety of answers. Okay. Make sure you get a big enough variety of answers so that you actually have interesting stem and leaf and an interesting histogram and an interesting box and whiskers plot. Does that make sense? You also want to make sure that people know how to answer the question. So don't make it too hard to answer, because then you'll have a lot of trouble with your study. So for example, if you say on average, how many times a month do you go to a restaurant? Most people don't really know. But if you say, how many times in the last month, in the last 30 days, have you gone to a restaurant? Most people do know that answer. Does that make sense? So try to make it a little easier for them to answer. That's just a survey design idea. Or any questions on that? Okay, or maybe the last 3 months so that you can get 2-digit numbers. Otherwise, you may not get any. Any questions on that so far? Okay, so again, single column of data. If you're having 2 columns or 2 groups, 2 things, there should only be 1 mean. If you have 2 means, you did it wrong. Does that make sense? So you just have 1 column of data. Okay. You have to interpret all the charts. And again, for each chart, what's the client going to do? Okay, how's the client going to use that information? Okay, you should have a list of the summary statistics, and you should interpret each of the ones that we've talked about in class. Okay, that includes, and in class means in the book too. That includes the mean. Actually, the variance, you list it, don't talk about the variance much because the units of variance are awful. I don't know if you realize that. If your survey was something like how much money did you spend in the last month in the grocery store, then the units of variance would be square dollars, which is meaningless. So don't even try to interpret the variance, sorry. But the standard deviation is a biggie. I even put capital letters on that guy. Okay, several other statistics, the median, maximum, the minimum, some of the easy ones are important. First quartile, third quartile, interquartile range. We've talked about that. Okay, pay special attention to the standard deviation. Okay, projects without a full paragraph devoted to the standard deviation cannot receive an A. So that's a big part. The standard deviation is a big piece. So in that standard deviation, the empirical rule uses a standard deviation. Chevyshev's theorem uses a standard deviation. Can you always use the empirical rule? Not always. When can you use the empirical rule? Who remembers? You remember? Last week, if your distribution is approximately normal shape, remember that normal shape? Okay, so you should look at the histogram. And if it looks kind of approximately normal, doesn't need perfect, then you can use the empirical rule. But if it's like totally skewed left, or if it's say bimodal, then forget it. You can't use the empirical rule. Then you have to resort to Chebyshev. Okay. You should look at z-scores. Okay, one way of using a z-score, by the way, is deciding if you have outliers. So you look at the minimum, find the z-score, see if it's an outlier. Remember, over 2 is an outlier, under -2 is an outlier. Over 3 is an extreme outlier, under -3 is an extreme outlier. So you can find the z-score and see if you have outliers. If the minimum is not an outlier and the maximum is not an outlier, there are no outliers. If the minimum is an outlier, check the one just before and see if that's an outlier. Do you see that? By looking at z-score. If you have anything that's like your standard and that should be a standard answer, like how many hours of sleep, if your question was how many hours of sleep do you get, then you probably want to look at the z-score of 8, because that's your standard number of hours that people recommend for sleep, and see what the z-score is. And if that's not close to 0, then that means people aren't being healthy. Do you see that? So that's how you interpret the z-score. Okay, talk about the importance of the findings. Make sure you look at the IQR. Okay, all the charts, recommendations. Again, you have access to this, so you can read all the words. I'm not reading every word here. Okay. And at the very end, maybe the highlights and also how you could do a further study. In theory, you don't actually have to do a further study, but how could you better do a study, maybe to reduce bias, for example, and also maybe other questions that you could ask that would give more information about what your client is interested in. Okay, doesn't mean you can do the study, but just things that would help in the future. Okay, I do have some feedback examples. I'll let you click on that and read some feedback that I gave in the past, and that'll help you see where common mistakes. I don't do an example project because I did that once and everyone copied and pasted it. So I don't do that anymore. But here's what I will do. Let me go back. I believe it's in here. I'll be happy to look at your rough draft of the paper. If you can email it to me by at least by 8 a.m. on Thursday before it's due. But I want to let you know there's 60 students or so in the 2 sections. If you all wait till the last minute, I mean, these papers are like 8 pages long. I'm not going to be able to read all of them in just one day because it's going to be hundreds of pages to read. You see that? So what I do is I read them on the first come, first read basis. So if you email it to me on Tuesday, there's a good chance I'll get to you right away. Does that make sense? If you wait till the last minute, I'll get to it, but it might be Saturday when I read it. Do you see that? And then you don't have much time. So because you're last. So the earlier you get it, the earlier I'll be able to give you feedback. So here are some things I recommend. Step 1 is partners. Get a partner. Get 2 partners, even better. Have 3 of you as a group. Does that make sense? Okay. And I recommend doing that within the next couple days. This should be done. Hopefully it's already done for you. Don't wait on that one. It's not hard to get partners, but you need to actually post it on the discussion board and you'll find partners. Does that make sense? If you wait a week and a half from now, you may not find partners and you're screwed. Do you see? Okay, but if you post today, you'll find partners. Sound fair? Okay, that's step 1. Step 2, meet with your partners. You do not need, again, you can do this whole class online. You can meet via, Canvas mail, email. You can meet, you can give each other your phone numbers if you want. You don't have to, and talk. You can do a Zoom chat if you want to do that. Zoom's free for short chats. But meet, does that make sense? Make sure you communicate and come up with a plan. So step 2 is coming up with a plan. The plan is, what is your survey question? Who is your client? How are you going to conduct the survey? Are you going to use stratified sampling or use cluster sampling? And if you use stratified sampling, what's your strata going to be? If you use cluster sampling, what are your clusters going to be? Does that make sense? So that's step 2. Step 3, post your plan on the Project One discussion board. That way, everyone can see each other's plans and you'll get an idea of what works and what doesn't work. I will reply to your post and let you know modifications to make it work better. Does that make sense? Sometimes it'll be, well, your survey question is qualitative, this isn't going to work at all. Sometimes it's going to be, well, great survey question, but you're not really using cluster sampling because you're only asking one group. So you need to ask more than one group that represents. Okay, or your survey question, if you change these 2 words, it'll be a lot easier for everyone to answer, that kind of thing. So I'll give you suggestions. Does that make sense? I recommend doing that maybe in the next, maybe 7 days. Just note, always good to look. Project One's due February 12th. I know it seems like a long time from now, but time moves fast. So 7 days from now is the 24th already. Okay, then you know it's going to work, right? And by the way, hopefully you get it. I'm pretty quick at like grading and getting back to you and that kind of stuff. Have you noticed that, those of you who have tried? Okay. Electricity could go out, so that could happen. I lost it yesterday. It sucked for about a half an hour. But yeah, I never know if I'm going to get it back. But other than that, I get back pretty fast. So that's that step. Then step 3, after I've looked at it and, hopefully you have a good project. Step 3 is to conduct your study. So do your survey. Make sure you get over 31 people answering. That's important. Any questions on step 3? Okay, and depending on how you're doing it, it might take 3 or 4 days, it might take a week, but I recommend having it done by the end of this month. So in the next 14 days, in the next 2 weeks, have your survey done. Does that make sense? Okay, step 4 is go to the spreadsheet. This one, not the calculator I created for the homeworks and stuff. This one, I showed you this in the orientation. Remember, you can do file, make a copy. That's the first thing you do. Share it with each other so that you can all have it together. It says this is a Google Sheets. Yeah, at least double digit. If your data is all single digit, you can't do stem and leaf. Yeah. Okay, so you should have 1 column of data. This can't work, by the way, I only have 10. So you should have at least 31. Okay. And if the computer doesn't let you do a box and whiskers, again, if it's blocking you, some computers do that. I have some extra links you can use instead. It's easier to do it this way, but extra links are, doable. So that's step 4. Step 4 should take 10 minutes, which is put it into the data. So that can be done like on the same day or the next day. Does that make sense? That's just typing the numbers in. That's all you're doing. Any questions on that? Okay, then comes the next step. I think I'm on step 5, maybe. Step 5 is to write your draft of the project. And what I recommend is, share the tasks, decide ahead of time which part you're going to do, which part your partner is going to do. Does that make sense? And make sure you read each other so you can help each other. Them doing it doesn't mean you never look at it. Okay, so that's the next step, step 5. Step 6 is to email me. Okay, email me your project. And that could be just giving me, if you're doing a Google Docs, for example, you do a share and email me the share link. If you're using a Word doc, you can email me the Word doc, whatever you're using. Hopefully my computer can handle it. I don't have anything too fancy, but I can handle Microsoft, I can handle Google. So I can handle a lot. One of the pieces, by the way, in your project, you're going to go like this. And actually up to Z-score. Copy, Control C, and paste it into your project. This must be part of your project. Got it? By the way, sorry if we're going a little later than I usually go because project takes a while to talk about. Sorry, but we're almost done. Okay, so make sure that this part is actually in the project. Okay, copy paste. It's very simple, but you got to do that. Sound fair? And that way I'll be able to look at it, know that you use a spreadsheet, and also be able to make sure that you actually looked at the right numbers when you're referencing stuff. Okay. And same thing, you can copy and paste the histogram. You can copy and paste the box and whiskers. You can copy and paste the stem and leaf into your project. Okay, so I think what I say step, was it 6 was email it to me. I'll then read it. I'll email back, usually with 10 or so recommendations. So then your next step, step 7, I guess, something like that, is to look at my recommendations and address them in your project. Sometimes they'll be very minor. Sometimes they'll be a little bigger, depending on what went wrong. And then, what's your last step? What's the last step?
Turn it in.
Yep, turn it in. Turn it in. So you go to the project one and you submit it. And you submit it by sending you attach the document basically. And make sure, this is very, very important, that on your project itself has the names of everyone in your group, so that I give everyone a grade. Otherwise, you're screwing them now. Okay, that would be horrible if you left somebody out. Okay, again, not hard, but don't forget to do that. Only one of you needs to submit the project. If more than one submits, what I do, I only read it once and I put notes on only one of them. And usually it's the first one in alphabetical order. But only one of you needs to do it, because then I go and put the grade on each of your papers. And then your last step is the obvious one. Look at your grade. And look at the feedback I gave. I'll give feedback. And whoever submitted it, I should share my feedback, because what I do is I put notes on the paper itself. So share my notes with your partners. Does that make sense? And that's it. So I think I'm going to stop the recording, because that's pretty much what I want to talk about. Sorry if I went 4 minutes later than I tell you my maximum usually is. The project takes a while to talk about, though. And chapter 3 is tough. So let me go stop recording.